Welcome back, folks. We are going to focus today on atoms and subatomic particles, and we're really going to dive into how do we know how many protons, neutrons, and electrons are in an atom, and how do we notate the different types of atoms that are found in a given element. So that's really going to be our big focus today. Again, the little moles right there staring at us, so hopefully you'll get to see what that means here in just a couple of videos. So our learning targets today are pretty straightforward. We should be able to determine the number of protons, neutrons, and electrons in an atom based on a variety of information. So there's lots of different problems that can be asked here, but pay close attention, take good notes, and you guys will have no problems whatsoever. Let's take a look at some key vocabulary terms here. We're going to learn about atomic number, isotope, mass number, hyphen notation, as well as the nuclear symbol. So let's dive in. So just to start, the concept of atoms and subatomic particles, all atoms are not the same. As you know, atoms of different elements contain different numbers of protons. Now that number of protons is also known as the atomic number. And just to reiterate, it's always equal to the number of protons. It's also the whole number that's found on the periodic table. So if we look at your periodic table and you look at lithium, for example, lithium is number 3 on the periodic table. Therefore, lithium contains 3 protons. Helium has the atomic number of 2. Therefore, it has 2 protons. Hydrogen, 1 proton, and so on. So keep in mind that the atomic number is equal to the number of protons. If the number of protons changes, then the element changes. So the number of protons is very important because that determines what element you are looking at and what you're seeing on the periodic table. Now the number of neutrons and electrons can differ, yet we can still have the same element. So atoms of the same element that differ in neutrons are called isotopes. So for example, lithium may contain 3 or 4 neutrons, but will always have 3 protons. Let's look at the carbon atoms that are here. The carbon atom on the far left has 6 protons and 6 neutrons. The carbon in the middle has 6 protons and 7 neutrons, and the carbon atom on the right has 6 protons and 8 neutrons. So all of these are carbon, yet they are isotopes of one another because they contain the different number of neutrons. So again, they're all carbon, but considered isotopes of one another. So let's take a look at what's called the mass number. Now, most of the mass that's found inside of an atom is related to the number of protons and neutrons. Electrons have a much smaller mass than protons or neutrons. So the mass number is something that's used quite frequently. And again, that is the number of protons plus the number of neutrons. That gives us our mass number. So this can be written a couple different ways. It can be written as lithium-7, which is hyphen notation, or 7Li, which is the nuclear symbol. That indicates that lithium has 3 protons, again because it's lithium, and since the mass number is 7, it must have 4 neutrons because 3 plus 4 is equal to 7. Take a look on the right here. We also have one for helium-4 in 2 different notations. The hyphen notation is given at the bottom, helium-4, indicating that there are 2 protons, and since 2 plus 2 is 4, we have 2 neutrons. It's the same with the nuclear symbol up at the top. We have the element symbol, the mass number is 4, and the atomic number is 2. So this atom of helium contains 2 protons and 2 neutrons. Remember that the number of protons plus the number of neutrons is equal to the mass number. Now, in a neutral atom, electrons are equal to that of protons. Now, if they differ, it's known as an ion, and that's indicated with a charge sign. A minus indicates that there's 1 additional electron, while a plus is 1 less electron. I know that seems really counterintuitive, but think about the charges that are present. Electrons are negatively charged, and protons are positively charged. So if I have 1 extra electron, I am going to have 1 extra negative charge, which is why a negative sign is indicated. If I have 1 fewer electron, then I'm going to have more protons, which means that there is more of a positive charge. So look at the ones on the right here. We have Br, which is for bromine, and that has a negative charge. Bromine, because it's bromine, has to have 35 protons. I don't see any indication of any change in the mass number, so we'll say it has 35 neutrons. But because it has a negative symbol next to it, that indicates that it has 1 more electron. So therefore, this has 36 electrons compared to the 35 protons. Let's look at the one down below. Calcium, because it's calcium, has to have 20 protons. And because there's no indication of change in the mass number, we'll assume that it has 20 neutrons as well. But because it has a +2, or 2 plus next to it, that indicates that it has a +2 charge, meaning that there are 2 more positive charges than negative ones. We can't change the number of positive charges because that changes the element. So we have to change the number of electrons and reduce that by 2. So this calcium ion has 20 protons and 18 electrons. Make sense? I hope so. So let's do a couple practice problems here just to make sure we have a really good idea of what we're looking at. How many protons, neutrons, and electrons are found in an atom of iron 58? Well, we need to know 3 things here: the number of protons, the number of neutrons, and the number of electrons. In order to determine the number of protons, remember, that's the same as the number that's found on the periodic table. So if I get out my periodic table, I'll notice that iron has an atomic number of 26. The mass number is 58, and the number of protons plus neutrons must equal 58. So I plug into that equation in the second line and find out that the number of neutrons is 32. And because the atom is neutral, protons are equal to the number of electrons. So the electrons must equal 26. So my protons are 26, my neutrons are 32, and my electrons are 26. See how we figured that out? It's pretty easy once you know how to kind of go through rhythm and figure out how to find each bit of information. Let's do some more practice. So let's do a couple more practice problems together. How many protons, neutrons, and electrons are found in an atom of bromine 79? So let's see here. We were looking for protons, neutrons, and electrons, and we're given bromine 79. Well, we know that bromine, if we look at the periodic table, is equal to number 35. So we can say that it has 35 protons. I see no indication here of an ion, meaning that the electrons do not differ, so the number of electrons will be 35. Now remember that protons plus neutrons is equal to your mass number. Well, the mass number here is 79. So 35 plus n equals 79. I look at the number of n. I do a little math to determine the number of neutrons and find out that that is 44. So the number of protons, electrons, and neutrons, we're done. Okay, pretty straightforward here. Now let's work a little bit backwards. It says to write the hyphen notation and the nuclear symbol for an isotope with 28 electrons, 32 neutrons, and 26 protons. Well, let's do some work here. So we've got 26 protons, right? And that's the number that determines the element on the periodic table. So if we look at our periodic table, we know that we are dealing with iron, or the symbol Fe. I have 32 neutrons and 26 protons. Well, remember the mass number is 32 plus 26. Okay. So that's going to tell us that we have a mass number of 58. So we can write the hyphen notation as iron 58. Okay. The nuclear symbol notation will be Fe. The mass number goes up here. You can write the atomic number down here at the bottom for 26, again, just like what we showed before. Now, if we take a look here, we have 28 electrons and 26 protons. Well, that means I have 28 particles with a negative charge and 26 with a positive. So I have 2 more negatives than a positive. So this is going to be a 2 minus. And that's your hyphen notation and your nuclear symbol. Okay? Pretty straightforward there. Now, on your sheet, on your question for the lesson here, I want you to write this down because I think that this stuff down here is a bit more challenging. So I want you to write the hyphen notation and nuclear symbol for an element that has 31 protons. Let's go with let's go with 40 neutrons, and let's go with 30 electrons. Okay, so what I want is the hyphen notation in the nuclear symbol for something with 31 protons, 40 neutrons, and 30 electrons. So think about how we did that here. Think about how we determined the element, the mass number, and writing that out, and then also determined whether this was an ion based on how many negative and positive charges were present. Hopefully that makes sense, but we'll go through some more of this in class in a little bit. So hopefully now you understand that the number of protons in an atom is equal to the atomic number found on the periodic table, that the number of neutrons can differ, and by adding the protons and neutrons we get our mass number. And the number of electrons can differ as well, and that's based on what charge an atom might have. So hopefully you're able to determine the number of protons, neutrons, and electrons in an atom based on some information. Again, hopefully this makes sense to you, and we'll catch you next time when we continue more on atomic theory. Have a good day, guys. Bye-bye.